Okay, hello again, Falcons. So today we're going to talk about the triangle proportionality theorem. And what does that mean? Well, if a line is parallel to one side of a triangle and intersects the other two sides, it divides the sides proportionally. So what that means is if this, we'll call it line 1, line 2. So if line 1 is parallel to line 2, then A is to B as C is to D. Now, when we were first solving some of the proportions, some of you asked me questions about this. Could we use this proportion to solve? And I said, yes, we would. We had to, we're going to have to prove that that theorem is true. So if this line is parallel to this line, we know that the two triangles formed are similar to each other. This little one on top of the larger one. And so we know that their corresponding sides are proportional. So A is to A plus B as C is to C plus D. Now, from this proportion, we can see that this is true. Now let's just cross multiply and verify. So we have A times C plus D is equal to C times A plus B. So then distributing, we have AC plus AD is equal to AC plus BC. And now when I do this, I always just put my variables in alphabetical order. And so notice that they have an AC on both sides of the equation. So we have A times D is equal to B times C. So is this the cross product of this proportion? It is. So we can go back and say, so if this is true, then A is to B as C is to D, because we get the cross product A times D is equal to B times C. So that is the triangle proportionality theorem. So we can look at this next diagram and we can say, okay, well, if this line EB is parallel to CD, then AE is to 9 as 8 is to 12. And then cross multiply and solve. So then we have 12 AE is equal to 72. AE then is equal to 6. So is 6 to 9 the same as 8 to 12? Yes, indeed. It's a 2 to 3 ratio. Okay, in the next diagram's a little bit trickier, and we look, okay, if this whole side is 30, this piece is 9, that would make this little portion 21. So we could write x plus 6 is to x as 21 is to 9. So we have this side is to this piece, this side is to that piece. When we cross multiply here, 21x is equal to 9x plus 54. What is 21 minus 9? Is that 12? So 12x equals 54. X is equal to, is that 4.5? 54 divided by 12, 4.5. Well, would you look at that? So x equals 4.5. But now to solve for y is actually one of the sides of the triangle. So we would have to use the corresponding sides of the two triangles. So we would have 21 is to 30, because that would be our scale factor, as 24 is to y. So then let's see, 30 times 24 is 720. So 21y equals 720. 720 divided by 21 is, that doesn't, 720 divided by 21. Oops, I did divide it by 31. 720 divided by 21. 34.3 approximately. Okay, so this shortcut, we don't want to let it fool us. So let me just write it again. If we have a parallel line parallel to a third side of the triangle, the corresponding sides of the similar triangles are proportional. So we would have A is to A plus B as C is to C plus D as E is to F. Now, the triangle proportionality only is A is to B as C is to D. So we have to be careful. If we're ever looking for the lengths of the parallel sides, we have to use CSSTP. Okay, so that's a little fact to put into your memory bank. Don't make that common error. Okay, and then the converse of that statement is also true. So if we know that these two sides are divided proportionally, then those two lines are parallel. So looking at this next diagram, can we conclude that PQ is parallel to LM? Well, let's check. 16 is to 18 as 24 is to 27. Now, we can either reduce those fractions or cross multiply and see if we have an equality. So 16 times 27 is 432, and 18 times 24 is 432, so we're in business. So then, yes, they would be parallel. The next example, and now here I said 16 is to 18. Can you see that I could have also said 18 is to 16 as 27 is to 24? So here, if I wanted, I could say 10 is to 12 as 16 is to 18. Now, is that going to be true? 10 divided by 12 is 0.8333, repeating, and then 16 divided by 18 is 0.888. So, are they parallel? No. Okay, so the same is true. It's like the triangle proportionality over parallel lines. If three parallel lines intersect two transversals, then they divide the transversals proportionally. So I think about this as if this were a triangle and we separated those two sides, making two transversals. We would have A is to B as C is to D. Those transversals are divided proportionally. So let's see. If I have 3, 6. Put this one on more of a slant. If this is 4, guess what this one's going to be? It's going to be 8. So many students ask me if, because I would check it, the transversals, here's a transversal, here's a transversal. I would check it, transversal 1, 3 is to 6, as 4 is to 8. Well, many students say, Mrs. Sharp, can I say 3 is to 4 as 6 is to 8? Well, will that work? Sure, it works, because look what happens when you get the same cross product, don't you, if you do it that way? So that is one of the properties of proportions. If A is to B as C is to D, we could say A is to C as B is to D, right? Because we still get the cross product, A times C is equal to B times D. So, so I gotta watch my time. So setting up the proportions, here I would say 12 is to 16 as X is to 18. Cross multiply and solve, I think you guys can do that. Here, it tells us here, with these notation, angle 1 equals angle 2, which equals angle 3, which equals angle 4. So L, M, and N are all parallel. So that's what makes this one a little bit more confusing. So we have two transversals intersecting 3 parallel lines. So they would be divided proportionally. So we could set it up 21 is to 28 as DE is to 32. Cross multiply and solve. Now, this next example, I thought we were in for a challenge here with this one. It says this diagram represents a tract of land being developed for homes. Which lot has the greatest perimeter? Well, if we look at all these numbers, the frontage here on Webster Street, we have 3 parallel streets. We have this one has an 80 yard frontage, 120 yard, 150 yard. And then we know that this piece is 40, 80, 110, 130. And then we note that this whole center street is 371.9. In order to figure this one out, we're going to have to do a little bit of work. So I know that these parallel lines divide these two transversals proportionally. So we would have to take this piece, make that whole piece 1, and put this as an x. So I'm going to do 150 is to 200 as x is to 371.9 minus x. And then once we figure out what lot C has, then we'll know what the length of these two is, and we'll be able to go from there. So in an effort to save time, I think we're going to complete this one on Thursday because my video can't be too long or it won't post to YouTube. Okay, to be continued, because I want to get this other theorem in. The other theorem is the triangle angle bisector theorem. Now, what does this mean? If a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other two sides. So, if I know that this ray is an angle bisector, so if these two angles are equal, what this says is that this ray bisects this, or divides this side proportional to the other two sides of the triangle. So A is to B as C is to D. Now, why would that be true? How are we going to prove something like this? Well, let me do a real quick proof for you. So I'm going to, because there's not much to go on here, so what I'm going to do is I'm going to draw a line parallel to the angle bisector through this point here. Am I allowed to do that? Sure, because through any point outside a line, remember exactly one parallel can be drawn. So if I draw that and make it parallel to this guy, extend this here. Does this look familiar to you? Well, it should, because what I just did is I created a triangle here with a line parallel to two sides of a triangle. So I'm going to call this E. So I can set it up that C is to E as A is to B, right? And now looking here, so we're almost there. Is it possible that E is the same length as D? Well, I know that this angle is equal to this angle because I made this line parallel to this. This angle is equal to this angle because corresponding angles are equal. And since these two angles are equal, these two angles are equal, making this guy an isosceles triangle. So D is equal to E because sides opposite equal angles are equal. So isn't that cool? So we can use substitution, poof, and we have that theorem. So what it says is that this side is divided proportional to the other two sides of the triangle. Now let's do an example of that. So in this first example, it says if angle 1 is congruent to angle 2. So that means that this guy, this line right here, is the angle bisector. Now it says the angle bisector divides the sides proportional to the other two sides of the triangle. So we would say 10 is to 14 as 17 is to y. So then the length of y, let's see, 14 times 17, whoops, 14 times 17, 238. So 10y is equal